Okay, so trig identities. Some of these identities you're going to have in your formula booklet, so it'd probably be a good idea to go back and look at your formula booklet and see which ones you need to know and which ones are going to be given to you. But these are some of them we've already talked about at the top here. All right, so this beginning part is literally just adding like terms. 3 cosine theta plus 4 cosine theta is 7 cosine theta. Any way that you can combine and simplify things down, that's kind of the goal of this whole lesson. Tangent minus, so 1 tangent minus 3, negative 2 tan alpha. So with Greek angles, we always use Greek letters. Theta, alpha, stuff like that. So these are just several different angle relationships. I don't know that I would write all the words. I would focus on this. The negative angles, this is really just even and odd because cosine is even. If you plug in negative theta in, it just makes it positive. With sine, sine is odd, so when you plug a negative in, it makes the whole thing negative. I don't think any of these are given in your formula booklet, but I don't know that you necessarily will see them on the IB test either. They are kind of handy with this first part though. Tangent equals sine over cosine. We've talked about this one multiple times. Okay, so anytime there's something with theta inside, you're going to have to do something to simplify it. You can never just leave it like that. So if we look up here, sine of negative theta equals negative sine theta. Plus, because notice we couldn't add these because they're not like terms. This is negative theta, this is positive theta. So our goal is to replace everything with positive theta because now we have like terms. And you don't need the 1, but I'm just showing negative 1 plus 2 is positive 1. Letter B is a little trickier. So if we find cosine of pi over 2 minus theta, that's right here. Notice this is just shifting cosine. So that's when we shift cosine, we get sine. We don't even need all the inside part. We shift cosine different directions to get sine. All right, then we're going to look at the supplementary up here. Cosine of theta pi minus theta is just negative cosine. And sine over cosine, I'm going to keep this negative out front. Sine over cosine is tangent. So we're just using identities to simplify a more complicated problem down to an easier problem because that'll allow us to solve more things. The Pythagorean identity, we've talked about this one multiple times. Sine squared plus cosine squared equals 1. Then we just can rearrange it. If I want to get sine squared by itself, do you see I could just subtract cosine squared to the other side? That's this version. Or I could get cosine by itself by subtracting sine squared. So all 3 of these are all the same equation, just in different order. Just using algebra to rearrange. Okay. Number 12, what we want to do, we can actually do number 12 a couple different ways. Notice that they each have a 2. There's a GCF of 2. So if you factor out that 2, we get 1 minus sine squared. Now 1 minus sine squared, we go up here. 1 minus sine squared is the same thing as cosine squared, so I can just replace 1 minus sine squared with cosine squared. What's really, really important, you can only do this if everything is squared, because it's the Pythagorean identity, sine squared, cosine squared. Technically, we even have 1 squared because 1 squared is 1. So you can only do this substitution if everything's squared. What's the GCF in this one? They both have sine theta in common. If you factor out the sine, I'm left with cosine squared plus, I take 1 sine out of sine to the third, I'm left with sine squared. Just like your x, if you factor x out of an x to the third, you're left with x squared. Okay, we treat sine, cosine, whatever, just like your x's. Oh wait, what is cosine squared plus sine squared equal? Ding, 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 ding. This whole thing always equals 1. And sine times 1 is just sine. Now, always make sure you keep the theta or whatever variable is being used all the way throughout the problem. Okay, so let's think about if I had x minus y squared, how would I simplify? Well, squared means I just take it times itself, distribute, combine like terms, and usually people are much more comfortable with variables than they are with trig variables. You don't do anything any different, you're just writing trig functions instead of x and y. So if I take cosine minus sine squared, you're taking it times itself, so distribute the cosine, cosine squared, cosine times cosine, minus cosine sine. Now distribute negative sine. Now keep in mind, well, I'll talk about that in a minute. And then negative sine times negative sine is sine squared. Now look at this right here. Is cosine times sine any different than sine times cosine? If you're multiplying, it doesn't matter. See, like over here, when we were multiplying, I just put the x first both times, and then I had 2 of them. It doesn't matter which one you put first, but they're both negative, so I have 2. If you want to do cosine sine, it's fine. If you want to do sine cosine, it's fine. But these two are like terms, so you can put them together. Then I'm going to switch the order here. Make this cosine squared plus sine squared. Ding, ding, ding. This is really important to always recognize. That's your Pythagorean identity. So anytime you have cosine squared plus sine squared or sine squared plus cosine squared, because once again, when you add, the order doesn't matter. This whole thing is just 1 minus 2 cosine sine. All right, so now we're going to do a little factoring. So here is the difference of 2 squares. So I need 2 parentheses because there is not anything in common. How do I get cosine squared? Cosine alpha, cosine alpha. How do I get sine squared? Sine alpha, sine alpha. Negative means 1's plus, 1's negative. That's it. All right. this always kind of trips people up a little bit. I want you to think about, if I asked you to factor this trinomial, two parentheses, x and x, factors of 2 that add to get 3, minus 2, minus 1. This is the same process, it's just your variable is tangent. So we do 2 parentheses, we just break apart tan squared into tan theta, minus 2, minus 1. See how it's the exact same thing using x's? And there are times where, as you're getting used to this, some people will just change all the variables into x's, do the problem, and then just turn it back into tangent for the answer. That is totally acceptable. All right, last 2 problems. We're now going to combine everything that we've been doing. So the first thing we're going to do, there's a GCF of 2. Do you recognize this? It's kind of, they're putting everything together. So first I factored out my GCF of 2. Now I need to, this is 1 plus cosine, but this is 1 minus cosine squared. I need to double parenthesis. I need to factor. I don't know why they always say factorize and IB, but we're going to factor the 1 minus cosine squared, difference of 2 squares. How do I get 1? 1 and 1. How do I get negative cosine? A plus cosine theta minus cosine theta. This is my numerator is completely factorized. Bring down the denominator, and we now have a factor in common, so we can cancel from top to bottom. Now, the big thing here, you cannot cancel until everything is being multiplied. You can only cancel factors, and then just write what is left. Okay. All right. The top cannot, nothing can be done because there's no squares. In the bottom though, so I'm just going to bring down my numerator. I'm going to factor the denominator, cosine, cosine, plus sine, minus sine. I always tell people minuses connects that whole numerator together. This is all one piece. And what does this cancel? It cancels all of that on the bottom. Anytime you cancel the entire numerator, you're left with a 1 on the top. And what's left on the bottom? That's your most simplified answer.